Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. In the previous class, we have discussed about two numerical problems based on Newton's laws of motion. Today, we will be discussing further two numerical problems based on Newton's law of gravitation. Okay, so without wasting time, let us jump to our topic today. You can take out your pen and copy, because when you are solving numerical problems, it is very important that you solve the problem by writing in your copy. Okay, so let us see. These problems that we are solving have been taken from the conscience physics book. Okay, so I am writing the questions for their convenience. If anyone does not have the conscience physics book with him or her, then also he can follow the class. Okay, so let us see what is the question saying. What is the question given? Okay, so the question number 1 says something like this. Okay, a ball is thrown vertically upward. Okay, very good. A ball is thrown vertically upward. Okay, fine. Okay, it goes to a height of 20 meters. Fine. It goes to a height of 20 meters. Okay, and then returns to ground. Okay, and then returns to ground. Okay, returns to ground. Then what else has been said? Taking the acceleration due to gravity as 10 meters per second square. Okay, so we have to calculate, find. Subpart 1 says initial velocity of ball. Initial velocity of ball. Okay. Subpart 2 says final velocity of ball on reaching ground. Final velocity of ball on reaching ground. Okay, reaching ground. And what else? Third part has been asked about the total time of journey of ball. Total time of journey of ball. Okay, so these are the things that have been asked in the question. Okay, fine. So how can you solve it? So as I have said in the previous class also, it is very important that when you are solving any numerical problem in physics, first of all try to summarize or try to just note down what are the given information, what are the informations that are provided in the numerical. Okay, so I hope you have written the questions. If not, please pause the video and write down the question. It will be easier for you to understand the problem. Okay, the solution. Fine. So I am just erasing it off so that I can utilize the entire space available on the board. Okay, it is better if you just copy the question. If you have not, please pause the video and copy the question. And again I am saying that if you have not seen the previous videos regarding Newton's laws of motion, Newton's laws of gravitation, please do watch all those videos, because when you are trying to understand the solution, we will be discussing many of the facts that we have discussed in the previous lectures. So it will be helpful for you to understand the solution. So please do all the videos. Okay, so it has been said that the ball is thrown vertically upward. It goes to a height of 20 meters. Okay, so what are the given informations? First of all, the ball is being thrown upward. It goes to a height of 20 meters. So given height, let us consider it to h. It's 20 meters. Fine. What else has been given? Acceleration due to gravity has been taken as 10 meters per second square. Okay, fine. Now we have to find out the initial velocity of the ball. Okay, so when you are considering the initial, or when you are trying to find out the initial velocity of the ball, what you need to do, solving the first part of the problem. Okay, initial velocity of the ball. So let us consider, let initial velocity of ball be u. Let initial velocity of ball be u. Okay, Now, so if it is u, then when it reaches the topmost height, what happens? The velocity of the ball comes to rest, isn't it? So the topmost, at the topmost height, the final velocity during the upward journey, final velocity of the ball becomes 0. So if we have to find out the initial velocity, so we have a, this acceleration due to gravity is basically the a provided in the equation, isn't it? So height 8 is 20 meters. So if we utilize the equation v square equals to u square plus 2as, okay, we are utilizing this equation, v square is equal to u square plus 2as. Now here s is the height h, a is the acceleration due to gravity g, v is the final velocity, and u is the initial velocity. Okay, fine. Okay, so from this, how can we get the value? See, as we are throwing the ball in the upward direction, okay, first remember one thing, that we have already learned about the scalar and vector quantities, isn't it? Scalar and vector quantities. So when you are considering that the ball has been thrown up, okay, so actually what we do, anything that goes up is taken as positive. We can think it like this, you can take it as positive. So when the ball is being thrown up, it is taken as positive, and when it comes down, it is taken as negative. If you don't want to solve it by the vector method, you can also think of that when you are throwing the ball up, the acceleration, the force due to gravity, what it is doing, it is trying to pull down the ball, isn't it? It is trying to pull down the ball. So what happens? The acceleration actually it is acting as a retardation for the ball when it is going up. Okay, so here when we apply this equation for the upward journey, what do you do? For upward journey, okay, we can consider the a as it is acting as deceleration, retarding force a to be minus 10 meter per second square, okay, as it is actually retarding the motion of the ball, 10 meter per second square minus value, okay. So with this, if we just put these values here, so you can write it like this, x0 square is equal to, you have to find out the u square, u value, plus 2 into minus 10 into 20, okay. So this can be the equation written like this, isn't it? Okay, so from this we can easily calculate the value of u. What is the value of u here? So here it turns out to be like this, okay. So u square is equals to, take it on that side, 2 into 10 20, it's 400, okay. So value of u, I think, is it visible? Okay, it's visible. So u square is equals to 400. So value of u is equals to square root of 400, okay, and that turns out to be 20, okay. So this is a solution. So we can actually get the value of the initial velocity has to be 20 meter per second. So what is the value of the initial velocity? It is 20 meter per second. I think now it is visible, yeah, okay. So answer is, first part answer is that u is, therefore u is equals to 20 meter per second, okay. Now let us move on to the next part. Second part says, what is the final velocity of the ball on reaching the ground? So when it reaches the ground, what is the final velocity? See, that is one concept, that when you throw something upward with a certain velocity, it goes up at the highest level, stops there, that is, it reaches a value of velocity where the velocity becomes 0. Then again when it starts falling down, it is being attracted by the earth, okay. That means a constant acceleration is acting, and the acceleration is in the direction of motion. So what happens? The velocity once again starts increasing from 0 to some value, to a certain value, and it has been experimentally found out that when the object hits the ground back again, it attains the same velocity with which the object was thrown up. This is the theoretical concept. Now we can also cross check this using the numerical concepts or numerical solution way, okay. So second part, you have to find out the velocity when it hits the ground. So during the downward journey, once again you can use this equation, v square equals to u square plus 2s, v square equals to u square plus 2as. Now during the downward journey, okay, for downward journey, okay, when the ball has reached the maximum height and it attains a zero velocity there, isn't it? When it reaches the maximum height, okay, say a ball, it has been thrown from the ground, okay, from here. When it goes up, it reaches the maximum height here, the velocity becomes zero here, isn't it? At the highest point, the maximum height, what happens here? The velocity becomes zero, isn't it? Velocity becomes zero. So when during the downward journey, if we consider this to be an initial point once again, so we can consider that downward journey u is what? 0. What is 0? Okay, and we have to here find out the final velocity. So let velocity on hitting ground be v. Velocity on hitting ground be v. Okay, hitting ground be v. Okay, so putting the values here, what do you get? So consider, so we can write it as v square is equals to u square is 0 square, and again when during the downward journey, what happens? The force of gravitation is actually assisting the motion, it is increasing the velocity of the motion. So here the value of acceleration can be considered to be as positive. Acceleration can be considered to be as positive, a equals to plus 10 meter per second, as because it is assisting the downward journey, okay, it is causing the velocity increase, so it's acceleration, so you can consider it to be 10 meter per second square, positive. Okay, so here it turns out to be something like this, plus 2 into positive 10, okay, into it's 20. Okay, so again the velocity when it is going up, what it becomes? It again becomes, when it hits the ground is again the same value is coming 400, as I said that it will have the same value as when being thrown up. V is equals to again 20 meter per second. So 20 value is coming. So you can say therefore final velocity when hitting the ground is again 20 meter per second. Okay, fine. So this is the value. So you can see that actually you can cross check our theoretical concept, that yes, the mathematical calculations also do support our theoretical concept. Yes, when it falls down, it has the same velocity once again. Okay, when as with which it has been thrown. The total time of the journey of the ball has to be calculated. Now, remember one thing: when it throws something up, it takes certain time to go up. Okay, say if it takes t time to go up, when it falls down from the maximum height, it again takes the same time to come down. So while coming down also it will take the same time t. So if we can just find out the value of the time when it is going up, we can easily just multiply it by 2 and get the value of the total time of the journey. So for determining the total time of the journey, what you need to do? We can again simply apply the equation v equals to u plus 80, isn't it? V is equals to u plus 80. Okay, so we have already seen that the initial velocity while being thrown up is actually 20 meter per second. So if we consider this the upward journey and take the time to be t, okay, so we are considering the upward journey and time taken for the upward journey is considered as t. So time taken for upward journey, okay, be it t, okay, fine, okay, no problem. Now when you see, so can we consider that during the upward journey initial velocity was 20 meter per second? Yeah, we have already calculated this value, and the acceleration should be taken as minus 10 meter per second, at least as it is opposing the upward journey, it's retarding. Okay, so you can easily utilize this equation. V is equals to u plus 80, and during the upward journey when it reaches the maximum height, what happens? The final velocity v becomes 0 here. So from this you can calculate the value of t here. So you can write it as 0 is equals to 20 plus minus 10 into time t. So from this you can say that time t will be equal to 20 by 10, that is equals to 2. So the time taken to go up is actually 2 seconds. So the time taken to come down will also be 2 seconds. So the total time of journey will be 2 multiplied by t, that is double of this time. Total time of journey, as you know, will be double of the time taken to go up. So it will be 2 into t, as we have calculated t to be 2 seconds. So it's 2 into 2, it's 4 seconds. Okay, so this is your answer. Fine. So I think the solution is clear. Okay, so in today's class we will end it here, as because time is not permitting us. We will solve another problem on the next class. Today we will be ending it here. Please do remember the concepts that you have discussed. It will be helpful for you to solve the numerical problems. Okay, so till the next class, please do study well. If you have any query, please mention in the comment box. We will be happy to solve your problem. With that, we will end the class. Thank you.